Welcome. This is Dr. Mercola helping take control of your health, and you're in for a real treat because I'm interviewing myself today and going to do a solo podcast to go about a very important topic, somewhat philosophical, but also very biologically practical. And it's related to the topic of the sun, one of my passions, and one of the reasons I became so interested in vitamin D a quarter of a century ago and been teaching about it and written papers about it, because one of the benefits of the sun, of course, is to get and optimize your vitamin D levels. Is the best way to get vitamin D. Certainly, most of us do not have the opportunity to live in environments where that's possible. And as a result, most of the year, or a large portion of the year, many of us have to supplement with vitamin D. And I think that's a lesser of two evils. I think it's far inferior to get it from the sun, but many of us, as I said, don't have that option available to them. And even if you lived in an environment where it's possible, many of us are working indoors and have to pay the bills, and that doesn't involve the opportunity to go outside on a regular basis. But when you do get your vitamin D, you see vitamin D, the levels have been long associated and correlated with longevity and improvement in health. This was before they were really vitamin D supplementation was popular, which didn't really become popular for pretty much the last 20 years. But many of these studies were done in the last century, and this was shown. And one of the reasons, of course, is vitamin D, but the other reason is one that really wasn't accounted for, and that's the other benefits of solar exposure. And one of them is that it is the source of energy. And just like plants cannot thrive without the sun, we're very similar in many respects. But it gets somewhat complicated. With plants, they go through a process called photosynthesis. This is where the sunlight shines on the plant, and there's chloroplasts, these little structures within the cells, which convert the solar energy to structural energy, and they actually make glucose. And they consume carbon dioxide as a fuel, and they produce oxygen as a waste product. So the photosynthetic process is actually what's responsible for producing oxygen in our environment and lowering the CO2 level of the atmosphere. But prior to the development of this, for the most part, there was no oxygen in the environment. And the bacteria that lived here were primitive and could not tolerate oxygen. Oxygen is a toxin. It literally is a molecule that will cause them to stop living very shortly. It's a poison, an absolute poison. And we still have many descendants of these bacteria in our colon. They're called obligate anaerobes, and these are the bugs that cannot tolerate oxygen. Interestingly, and this is not widely known, most of the bugs that have these obligate anaerobes, this feature, these are the beneficial bacteria in our gut. These are the good guys, the ones that are damaged when we don't have enough cellular energy, which is one of the foundational components of my unified theory of cellular health, is that when you don't have enough cellular energy, you're not going to have the resources to remove oxygen from your colon. And as a result of that, you're going to have an abundance of disease-causing bacteria, also called pathogenic bacteria, and also given the term facultative anaerobes. Anaerobe simply means without oxygen. Anaerobic, without oxygen. Aerobic means with oxygen or air, and an means without air. So a facultative anaerobe is an organism that can survive in an environment without oxygen, but can also tolerate oxygen, a small amount. And because it can tolerate oxygen, it actually uses as a substrate for fuel, it can generate more energy. And one of the consequences of that for you and me is not really good. Because they have more energy, they can create an endotoxin, which is in their cell walls, and the good guys, the obligate anaerobes, and the bad guys, the facultative anaerobes, both have endotoxin. They're both gram-negative bacteria. And endotoxin is a sort of a combination molecule. It's called a lipopolysaccharide, and lipo means fat, and polysaccharide is a combination of a polymer, essentially, of glucose. So or sugars, more specifically, many sugars. May not be glucose molecules, maybe some other sugar. But essentially that's what it is. It's a combination of these, and it's very toxic. Once these organisms grow and they die, they secrete the toxin into the local environment, and it can cause a lot of damage, especially the ones from the facultative anaerobes. So anyway, one of the ways that your body is designed to get energy is sort of using the middlemen. What I mean by middlemen, I mean by the food that we eat, the fats, the carbs, and yes, there's protein, but protein is rarely or uncommonly used as a energy source. So yes, you can digest it for energy, but it's not a net positive. It actually costs you more energy to burn it than to use it as than it costs to remake those proteins. So in some ways, it's like drinking seawater. Yes, it's water in it, but the salt in it is a net loss, and you will die of dehydration if you're drinking seawater as your only source of water. Not a good thing. That's why people die of dehydration when they're stranded in the ocean, because they can't drink the water. Similarly, you don't want to use protein as your primary source. Sometimes you have to, but it's no choice. But essentially, your primary fuel sources are fats and carbohydrates. So, but there's another fuel source, and which is the context of this this video that I'm shooting for you. The context is that we were designed to get a significant amount of fuel from the sun. Significant. And I'm actually in the process of doing some experiments because I've spun up a lab, full-blown mitochondrial research lab, to identify some theories that I've come up with and support them. And I'm going to most likely be finished with these investigations and these experiments and hope to publish this by the fall. But the crux of the theory is there's a mechanism, biological mechanism that we all have that has the ability to take sunlight, and just like the chloroplasts do with photosynthesis, they convert that sunlight into a storage form of electrons. Because electrons are the fuel that gets going. When we eat food, it supplies us with a source of electrons. And those electrons are shuttled around your body through a variety of different processes, first digesting the food in your intestine, and then having the food wind up ultimately in the cells. And in the cells, it goes through a process where it's converted ultimately not proteins, but fats and carbohydrates to a little tiny molecule. It's called acetyl coenzyme A. And it's a 2-carbon molecule that gets shuttled across the mitochondrial membrane, and inside the mitochondrial matrix, there's this set of enzymes called the Krebs cycle, and the Krebs cycle takes that coenzyme A and converts it to electrons. Yes, electrons. And they have little carriers on them. They're typically 2 types of carriers. One is NADH and the other is FADH2. Those carriers shuttle those electrons into the electron transport chain. Isn't it interesting? It's a really good and accurate name. It transports electrons through a series of proteins that are called complexes, and there's 5 of them, but only 4 actually process the electrons. The 5th one is one that actually takes the benefit of having all those electrons, which is a concentration of hydrogen ions in the intermitochondrial space. And it's this little mini motor that moves about 100 times a second, maybe 9,000 or 6,000 times a minute, rotating very fast. You could not see this because it's going so fast. It just looks like a solid motion, a solid wall. But every time it spins, it shoots us an ATP molecule. And our ATP molecules are quite extraordinary. We make one mitochondrion makes 100 ATPs a second. You have more than one mitochondrion in a cell. Well, actually, one electron transport chain makes 100 ATP per second. In a mitochondria, you might have 100,000 electron transport chains. So you're making 10 million ATP molecules every second. And that sounds like a lot, but you've got 40 quadrillion mitochondria. So you multiply 10 million times 40 quadrillion, you're looking at 400 million quadrillion ATPs a second. That's a lot of ATP, folks. And when you add those all up, if you were to weigh them, and imagine weighing an ATP molecule, I don't even know that it's possible other than through a calculation. But collectively, in one day, the average person, if they're healthy, is making enough ATP in a day that is equal to their body weight. That is the fuel your body runs on. That's the energy currency. And it's produced from electrons. Most of us get the electrons from the food. It's important. These are basic facts of biology that many people don't understand and appreciate. So my theory, the unified theory of cellular health, is that if you're not making enough energy, if you're not creating enough ATPs, if you're not creating your body weight in ATPs every day, you will suffer. You will die prematurely and you will be miserable. You'll have fatigue. You'll have pretty much every chronic degenerative disease known to man as possible if you don't have enough cellular energy. So the key is to restore that cellular energy. And one of the ways that you can do it is through the sun. Now, there's a paradox I've always wondered about, because I've been practicing medicine for 4 decades. And in that time, I've encountered people, many of my patients, and I'm sure you know people, maybe you're one of these people yourself, that claim that when they go into the sun, which is literally one of the healthiest things a human being can do, if a healthy human being can do, these people, when they go in the sun, they get worse. Their body screams in them, don't do this. You're making me worse. So one of the reasons it does this is it helps. Well, just the fact that it gets worse, first of all, highlights and reinforces a concept I want each and every one of you to understand, and that is always trust your body. Your body will never lie to you. So if going to the sun is supposed to be healthy and then you get worse, do not go in the sun. Do not go in the sun. Don't do anything that your body is violently opposed to. That includes anything I say. What I'm doing, it seems to help my biology, and it helps the biology of many people that I interact with. But it's not for everyone. So you always have to trust your body. That's a central, really foundational principle that you want to understand, acknowledge, and apply. So getting back to this paradox, how could possibly going into the sun make you worse? Well, when I put this unifying theory of health together, which integrates cellular or solar energy to increase cellular energy, I began to understand that there's this biological mechanism. So I'm going to elucidate in another book and papers that I'm writing. It'll be accepted for peer-reviewed publication. Because we're doing this, as I said, we're doing the experiments right now to confirm this. This biological mechanism exists. It essentially converts photons to electrons, and they're transferred all the way into the inner mitochondrial membrane, right into the electron transport chains, a series of 5 proteins that convert the electrons to ATP. The problem is something I've just been discussing with Brad Marshall if you can just go back into the website and type in Brad Marshall into the search engine, you'll find the previous 2 interviews I've done. And they focus on a concept called reductive stress, which, don't let the title intimidate you, but let me just simplify it in some simpler language and concepts that you can wrap your head around. So when we say reductive, the root word of that is reduced. So it's important to understand, you probably know from any previous biology classes you took or chemistry classes, that electrons have a negative charge. So if you add, and the protons have a positive charge. So if you add things up and you have a surplus of electrons, you have a negative charge. And that's essentially a reduced state because electrons have a negative charge. So that's what we mean by reductive stress. That you have a surplus of electrons floating around. They don't float around, though. They collect. Electrons want to be used. And the way that your biology has developed is it's a very elegant system, is the electron transport chain. That's where they head. That's where most of these electrons wind up being processed. They go through the ETC, and there's a series of complexes, 1 through 5, but the 1 through 4 do most of the magic. And in each of those complexes, those electrons can get blocked. They can get stopped because if you have a surplus, it's a limited bandwidth that chain has. If you have too much in there, it's not going to go through. It'll stop. It'll plug up. It's kind of like if you've ever poured a liquid from a big bottle into a small one or a small funnel. If you pour too quickly, it's going to overflow, right? It doesn't go through. There's only a certain limit that you can push those electrons through. And if you exceed that limit, the electrons will stay there and they'll cause damage. Let me help you understand why they cause damage. Because in a healthy person, if you're making energy the way you had, and there's no bottlenecks, no stops, now please understand that most of us aren't healthy. Healthy people are far less than 5%, probably close to 2 to 3% of our population. And you should be very thankful if you're one of them, because most people are not. 97% of this country are not healthy. 97%. That's astonishing. And maybe not so much so. 70% of us are overweight. 70%. We're dropping like flies from all these chronic degenerative diseases. And it's because we're not healthy. And one of the foundational reasons we're not healthy is we're unable to create enough cellular energy. And one of the most common ways this occurs is through reductive stress. So let me continue to explain what that is. So you have this limited pipe that you can shuttle the electrons through. When they get plugged up, the electrons, in a healthy person, again, they're supposed to go all the way through to complex 4. And in complex 4, the magic occurs where you have molecular oxygen, which is the ultimate electron acceptor. Molecular oxygen accepts those electrons and it turns to water, which is water's absolutely no danger. It's actually the highest quality water you can get. It's called metabolic water, deuterium depleted water. It's the ultimate water. You make it in your cells every day. So you make a lot of it. That's where it's supposed to wind up. And when you do that, there's virtually very, very little, way probably under 1% of the oxygen gets converted to something called the ROS, or reactive oxygen species. And when these electrons get backed up in any of the complexes, 1, 2, 3, or 4, if they're backed up and they're not flowing through, that electron cannot be transferred to oxygen as the final ultimate electron acceptor. So at least molecular oxygen, and convert that to water in the magic of complex 4. So it does it before that because there's oxygen all around there. And the electrons combine with oxygen before complex 4, that is a problem. That causes a reactive oxygen species, an ROS. And those would be things like superoxide or hydrogen peroxide. And those can cause damage. Now, we need some of those molecules. They're important signaling molecules. But the problem is most of us have far more than we need. Far more than we need. So that is occurring in most of us. So not only do we not make the cellular energy we need, but we're creating what's called oxidative stress, because the backed up electrons, which is a reductive stress, one of the consequences of it is it spins off through the process I just described, reactive oxygen species, ROS, which cause oxidative stress. So reductive stress is the most common reason for oxidative stress. It's usually reductive stress. And what causes reductive stress is surplus of electrons. So you probably, why was I talking about the sun? What happened to the sun analogy? Well, I need to explain this concept to you first to understand why. If you go into the sun and you get worse, there's a reason for it. The reason is because you have reductive stress. It's pervasive. Most people have it. You have the surplus of electrons that's bottlenecked your electrons, or your ETC. It can't be processed, and you're going to create reactive oxygen species. So do not go in the sun if you have reductive stress. Unless you do two of the things I want to explain to you that is possible. One of them was to get rid of those electrons. The best way to do it, the biological way, the way we were all designed to do, because this is a common occurrence, is something called grounding or earthing. Now, I've known Clint Ober for 15 years, maybe 20, a long time. And I have a disagreement with him, and I've told him this personally, because he doesn't understand how the system works. He's a great human, no question. And I'm very grateful for him to bring this concept forward, because he's done massively great work in that respect. But he is of the belief that when you are grounding, you're picking up electrons from the earth into your body. Nothing. He has it completely backwards, and nothing can be further from true. It's the exact opposite. And it doesn't take a rocket scientist to figure it out. I'm sure all of us had the experience where we're walking on a carpet in a low humidity environment, like either a desert or the cold winter morning that in Chicago, where you don't have your humidifier going. You walk on the carpet and you touch a doorknob, a metal doorknob, and you're going to get a shock. Now, that shock is not because there's electrons coming from the doorknob into your hand. No, my friends, it's not. It's because there's a surplus of electrons. The reductive stress that you built up is grounded to that doorknob, because the humidity is low and not acting as an insulation, so you can finally make the connection from your finger to the metal, and you discharge the electrons as a spark. Sometimes it shocks us, but that's what you're doing. That's a good thing. You're releasing your surplus of electrons, which is good. The other way that you can do it, well, you could do it by grounding in North America, but the problem is most of us live in North America. And if you don't, that's great, because you don't have this complication, because our utility companies, like many of the industries in the United States, have been corrupted, doing things that are not necessarily good for the public, but for themselves and their bottom line. So they decided to cut corners and not put a return wire to the substations when they produce power, and they let the ground put it back. And what that does is put these high voltage transducers in the ground, creating something called dirty electricity, which contaminates the ground. So in North America, it's not a really good idea to ground yourself. That doesn't mean you can't walk on wet grass, and not get sick or anything, but it's less than ideal, because you're not just going to, in addition to discharging your surplus of electrons, you're also going to gain some unhealthy frequencies from the ground. So we don't recommend grounding in North America at all. Not a good idea. But unless there are two exceptions. If you live in a really remote area where most people there don't have power, you're up in a mountain somewhere, you're miles away from the nearest substation, then that ground probably is relatively healthy, and you could ground there. Most of us don't live in those environments. But the other common environment would be the ocean. And the ocean is such a large sink, massive sink, that it will accept those electrons. Plus, it has salt in it, and salt is a conductor. So it's not like going into a lake without salt. But once you go into the ocean, that is the ultimate grounding experience anywhere in the world. All the oceans, that you couldn't be in a better environment. It's one of the reasons why being in the ocean is so healthy, and one of the reasons why I live near the ocean, so I can do this practice every day, because I really do believe strongly that in an ideal situation, we're meant to be in the ocean pretty much every day, if at all possible, at least touch the ocean. So, and then get sunshine. So if you're a normal individual, less than optimally healthy, then not normal, but typical. Normal would be healthy. That's what we're supposed to be, but most of us aren't. So if you're unhealthy and you want to get sun exposure, as I highly recommend, and you don't get better, or if you want to just make sure you're getting better, ideally you get into a grounding environment like the ocean. Now, that's not going to be possible for most of us. Not many of us live close to the ocean at all. So this is like less than 1 in 10,000, maybe 1 in 100,000 people who will be able to do this. I realize this is a very small percentage of people. I'm just offering the different ways that you can get rid of or remove your reductive stress. The other way, you could take an oxidizing agent. The oxidizing agents will essentially accept those electrons. And one of the oldest, well, not one of the oldest drug known to man is something called methane blue. It was discovered as an industrial dye for blue jeans, actually. And then that was in the 1870s. And then about less than 22 decades, the really prominent physician, pioneer, Paul Ehrlich, discovered that you could use it to treat malaria they did. And in fact, it's not a widely known fact that methylene blue is a quinone, that it's a diquinone. So there were many quinone alternatives that were developed to make it more convenient for people to take, because they didn't like a blue tongue and staining their shirts and stuff when they took this methylene blue. So one of the quinones is chloroquine or hydroxychloroquine, a drug that's called Plaquenil. And many of you may recall that was one of the drugs that was recommended to treat COVID by a number of physicians. And it seemed to be helpful. There was others, of course, like ivermectin, which interestingly, both of those are antiparasitic. So I don't know what to make of that other than this is an interesting observation. But nevertheless, I think the primary reason it worked is it helped increase cellular energy, because not only did it have an antiparasitic effect, but it served as an oxidant to remove the reductive stress and help you make more cellular energy, because you require cellular energy to do almost anything in your body. You need this ATP. You need to make your body weight in ATP every day. If you're not, it's a problem. And most of us aren't. So the key to getting healthy is to doing this, engaging this in a regular way. So getting back to methylene blue, I think most of us would benefit from it. The problem with methylene blue, there's different grades. There's an industrial grade that is frequently contaminated with heavy metals. It's probably not a good idea to use this. I wouldn't use what you're using to clean your fish tank to remove reductive stress. Probably not a good strategy. I don't recommend that. But there are pharmaceutical grades, because methylene blue is a drug, which is why it's such a problem. And it's very difficult to sell, and many companies do sell it. But if any of these companies got big, they would be in deep weeds, and the FDA would come after them, because it's technically illegal. Anyone who's selling methylene blue in pharmaceutical grade without a prescription is in violation of the law. And I'm not saying that law is good or valid and should be enforced. I would think quite the contrary. I think it's a tool that the FDA uses to pressure people to make decisions in the wrong, to enforce their exclusion or control of the whole system. So, but nevertheless, it's still illegal. So, but fortunately, we can work within the guidelines of the law, and the guidelines suggest that it's a prescription drug. You need a prescription. Thankfully, you can get a prescription for this. Many doctors can drive it, and there are types of pharmacies called compounding pharmacists. They're not that common, but there's a number, and I could recommend one in this article that we'll link to that can provide that service to you. And then it's pharmaceutical grade, and it's perfectly legal because you have a prescription, and then you can use it. Now, what type of dose do you need? You don't need that much. Now, recognize that up until relatively recently, you could buy methylene blue as a prescription in the drugstore, but you can't do that anymore. They've taken it off the market. The drug that they used was urolithin, not urolithin, Urobid, I think. Essentially, methylene blue is about 50 milligrams. It was used to treat urinary tract infection. It still is a phenomenal treatment because it tends to concentrate in the bladder and essentially sterilizes the bladder. It concentrates in the bladder. Oh, it's excreted in the bladder, so we build up high concentrations. It concentrates in the mitochondria. This is almost a mitochondrial dye, which is why it works so well. It goes right to the electron transport chain and essentially accepts the electrons that are there, and it eliminates the reductive stress. It's a magnificent tool. You don't need much of it. You only need about 5 milligrams once a day. Half-life is 13 hours. If you're in bad shape, you can do it twice a day, but for a few days. But usually 5 milligrams is all you need, no more. Hard to measure 5 milligrams, which is another reason why you'd like to get it from a prescription pharmacy, because they will measure it for you. It's not going to be 2.5. It's not going to be 7 or 10 or 15. It'll be 5. You can be very confident if it's a competent compounding pharmacist that will be an accurate dose. And one of the ways that you can lower the price for yourself is you can get a 50 milligram capsule, which can be easily compounded. And that's 10 doses. So you don't take the 50 milligrams all at once. That would be unwise and expensive. So you can take the 50 milligram dose and put it into like 50 cc's of water, which is 50 cc's is almost 2 ounces. And then you can measure 5 cc's, which would be a tablespoon. And there's 10 5 cc's and 50 cc's, and you would have 10 doses. And you could use that for 10 days. So normally these capsules would cost $2 to $3 a piece to be compounded, which is kind of pricey for a medication. The cost of the medicine is pretty low, but there's a lot that goes into a compounding pharmacy, and they have significant costs to do them. They certainly have to make a profit, otherwise they can't sell it, right? So it's a fair price. But you can reduce your costs, maybe get a bunch of them, and then you can have enough for a year's supply. I don't think methylene blue is something you need the rest of your life. Once you implement the procedures that I discuss very carefully, very thoroughly, in very significant detail in my new book, Cellular Health, your body will start to recover and repair and regenerate, and you'll regain the ability to increase your mitochondrial function and the ability to increase cellular energy. And once you do that, then the underlying cause, which tends to be related more to the production of the bacteria, the transition of the types of bacteria growing in your colon, which is the key to this. It's a key to much of this work. So I probably could pivot a little bit to that now, because one of the consequences of not having enough cellular energy and the ability to exclude oxygen from your colon, because it requires energy to do that. It's just, otherwise it's a concentration differential. The oxygen in the atmosphere is 21%. Oxygen in your gut is supposed to be 0%. And to maintain that differential requires energy. There's an active process that goes about excreting the oxygen from the large intestine. Certain cells that do that, and those cells require energy. And if you don't give them the energy, they can't do it. And when they don't do it, then you have the shift of your type of bacteria growing in your colon. That, my friends, is one of the primary reasons that we are all unhealthy. Almost all of us are unhealthy, because we can't maintain that oxygen gradient. As a result, we develop these pathogenic bacteria that destroy our health. And one of the reasons they destroy it is they create endotoxin. Again, that combination of which is the lipopolysaccharide they embed in their cell walls. And when you feed them the right foods, which is pretty much fibers and things, you'll cause these bacteria to thrive and grow and multiply. And when they die, the endotoxin is released. And as I said, they have more energy. They can use oxygen. So they have a more virulent, a more dangerous endotoxin, one that can kill you, actually. And let me just mention this point for a moment, because it's really significant. In writing my book, I didn't realize this. I'd done articles with Paul Merritt before. I actually did an interview with Paul. And he's like really one of the world experts in septic shock, intensive care medicine. He's a pulmonologist, I believe, and really did a lot of deep work with it and did help many, many people, especially with his implementation of ascorbic acid, which, by the way, is an oxidant, reduces reductive stress. It's one of the reasons why it works, because it's an oxidant. That's why ozone works, which, by the way, I'm a huge fan of ozone. Ozone has saved so many people's lives. But I want to warn here, everyone here, remember what I said, that one of the primary reasons why you're sick is that you don't have cellular energy. And because of that loss of energy, you can't maintain that oxygen differential in your colon. And your oxygen level starts to rise. And that's when you get sick. So it's an obvious as can be, that the last thing in the world you would ever want to do is stick a catheter up your butt and put ozone in it. Yes, it might help acutely, but that's a prescription for metabolic disaster. Never do that. Use ozone in your blood. Use it in your mouth. Use it in your ears. Don't breathe it. Don't put it in your colon. That's the last place you want to put it, because when you're using rectal ozone, 97% or 93%, so high 90s of that ozone is oxygen. And the last place you want to put oxygen in your colon, it does not need to be there. It's only going to cause damage. It'll kill the good bacteria, which is you're just destroying the good bacteria you have. You just never do that. So, and the same thing goes for hyperbaric too. Now, hyperbaric is wonderful, a magnificent tool, but you don't want it in your colon, and you cannot avoid getting a colon unless you somehow do a hyperbaric on your head only, which would be wonderful, but I think it's biologically impossible without killing yourself. So I would be really, really cautious of that. It's only as a last resort where you want to consider hyperbaric when there's no other options available, kind of like what you'd consider using surgery for in some instances. So the key is to get that cellular energy up and eat the right foods and there's a lot more that I can go and discuss, and I will discuss in the book. It's so much more that I wrote a whole book about it, cellular health, which is, I'm not sure when we're releasing this video, but it might be before or after the book comes out, but it's an epic book. It'll be literally one of the best books ever written on health, because it reveals information that has never been revealed before. And which reminds me that I never finished the story about septic shock. Remember, septic shock is there because you have too many of the wrong bacteria. They're dying, facultative anaerobes, that have the virulent endotoxin in their cell wall. They die, they're released. They cause something called leaky gut, which is a literal hole in your intestinal wall that allows not only endotoxin to penetrate into your blood, but also other macromolecules like proteins. So this endotoxin destruction of the lining of your endothelium of your gut, your large intestine specifically, is one of the primary reasons why you get autoimmune disease, is because these proteins that are not supposed to be in your blood at all ever leak in because of the holes that were punched by the endotoxin. So the way that you fix this is to get those good bacteria up again. It's really, really almost impossible to do unless you're addressing the 4 pillars that contribute to the loss of your ability to produce cellular health. Endotoxin being one of them. The other 3 are simply linoleic acid, and I beat the drum about that for many years now. EMF, I've written a whole book on that. And then also estrogen. And estrogen, other substances that activate estrogen receptors, and those substances would be microplastics, plastics, phthalates, BPA, and industrial toxins like DDT, PBDs, flame retardants. These chemicals, one of the primary reasons they're so toxic is they stimulate the estrogen receptors. So there are strategies that you can use to lower the amount of these chemicals in your body and to actually compensate for the activation of the estrogen receptors. And I go into that very deeply into the Cellular Health book, because it's an issue each and every one is facing. I'm certainly no exception to that. I assiduously implement these protocols because estrogen is not many people's friends, despite what you think. I'm writing a whole book about estrogen in the future, but for the moment, just know that it's the activation of the estrogen receptors that contributes to the loss of your cellular health and destruction of your biology. So anyway, getting back to this, when you have large amounts of endotoxin released, in writing this book, I now understand what the number 1 cause of death is. Of course, it's loss of your ability to produce cellular energy. There's no question. That is the cause of virtually every single disease known to man. But one of the immediate consequences of that is the transition to this toxic microbiome that makes virulent endotoxin. And as a result of that, you have massive amounts of endotoxin circulating in your blood. That is not benign, my friends. I'm sure you've all heard of the term septic shock, but you should have heard about it much more. This information has been suppressed. I just put 2 and 2 together and connected the dots. And it's suppressed because there's some liability here. If we knew how common septic shock was, we would be up in arms. It probably is. And I uncovered this. When I understood this is just recently, it reminded me when I was sitting in my office in Chicago, my small 900 square foot office in the suburban northwest suburbs of Chicago called Schaumburg. It was July 2020, literally 24 years ago. And I, at that time, had a subscription to JAMA, Journal of the American Medical Association. And I don't know why I did, but I did. So I was reading in my office, and I saw this article written by Barbara Starfield, who has since passed, paradoxically, from physician error. But she was an MD, PhD out of Stanford, I believe. And she wrote this article on documenting medical errors. And if you looked at the charts, this was not in the headline of the article or in the abstract or in the conclusion. It was embedded in the data that she published. You just look at the charts and it was obvious. Physicians were the 3rd leading cause of death. So I wrote a meme on that with that, and it became very popular in the early 2000s. But I developed that meme after I read that article. I had the same feeling when I had this understanding that sepsis, if you just look by the numbers, It's the third cause of death, right behind and not far behind heart disease and cancer. But the reality is this chronic septicemia that we have, this endotoxin surplus in our bloodstream, degrades our biology so much, and it radically reduces mitochondrial function, that it is the cause of death, the primary biological cause of death. And what is mistakenly classified as a cause of death are what trigger that, like heart failure or diabetes or obesity or neurodegenerative disease, all which increase reductive stress, every one of those things. And when you increase reductive stress, you are destroying mitochondrial function, which worsens the oxygen gradient differential and worsens your microbiome. So you get in this vicious downhill spiral that is almost impossible to escape out of, at least in the long term, unless you know the tools that you can implement to turn this around. And it's taken me almost 50 years to understand these tools and put it together in a comprehensive tool that you can use as a book. Very specific, very precise, very easy to understand concepts that go much deeper than I did in this conversation with you. So I'm going to include some interesting graphics with this in this article, and a connection to the link for compounding pharmacists. And there's many compounding pharmacists you can do, so you don't have to use the one I'm suggesting at all. I have no relationship with them, no deals or anything. I'm just suggesting this is one that I know does a good job. There are many others. So that's a resource for you. But consider using methylene blue, pharmaceutical grade, prescribed by a physician, to lower your reductive stress. It's going to be helping you. It's not something you use the rest of your life. It's a crutch. Just like if you are playing a basketball game or you're in a sport and you break a bone, you're going to need a crutch. You need some assistance until your body rehabilitates. That's a no-brainer. That's obvious. It's the same thing. When you're metabolically injured, when you have lost or seriously impaired your ability to produce the amount of energy you need, your body weight in ATP every day, you're going to need some help. What's methylene blue can do for you? And you don't use it forever. You use it until you're able to implement a strategy to treat the cause, to reverse the consequences of those 4 variables I mentioned earlier. And you get on a program that does that, and then you won't need it anymore. You don't need it. I don't take methylene blue. I don't need it. And you won't need it either, but most of you need it, something like methylene blue all the time, or be in the ocean every day. Then you don't need it at all either, because you can discharge your electrons in the ocean. But you need something like that to ground yourself. And I said, I'd be cautious if you live in North America, use conventional grounding. I know people get benefit from it, but there's a downside that's not commonly appreciated. And there's a book written about dirty electricity, and I forget the author's name. He's an MD. I'm not sure if he's still alive, but I did interview him, and you probably could find his interview on my website in the search engine. So I'll even see if I can put a link to that, which talks about dirty electricity. Somewhat related to the topic, but it's tangential, but it's an important concept when you're trying to ground and remove the surplus, these bottleneck electrons that clog up your ETC and prevent you from making the cellular energy you need. So hopefully you found this useful, and will seriously consider getting a copy of my new book, Cellular Health. It's the best book by anything close. I've never written a book like this. I'm so proud of it. So excited to share this information worldwide. This could change 1 billion people's lives. No doubt in my mind. The potential is there. I'm very, very excited to see people's lives turned around and be healthy, because you all deserve to be healthy. Each and every one of you deserve to be healthy. So I strongly recommend you pick up a copy of this book. You'll love it. And it's give you the tools you'll need. It puts it all together like I've never done before, like I've never known before. This year has been a massively important growth year for me. And I've really accelerated my understanding of biology, in large part thanks to Ray Peat. He was a massive pioneer. And it's on the shoulders of giants like Ray that I started to understand biology in a way that I never did before. And I've taken some of his principles and refined them to a point that he didn't understand, but would have if he was still with us. But it's really thanks to Ray that I've been able to understand biology at a much better way that I ever had before in my life. So I'm so excited to share this knowledge with you and help you understand it too, so you can apply it and be healthy the way you were designed to be. So hopefully that's useful.